My name is Brynsvold, and I'll be talking to you today about my data science project, Literary Analysis with NLP, where I've done topic modeling on Project Gutenberg. So I went and I created a topic model on a large collection of ebooks. A quick roadmap for the presentation today. So we'll be doing a high-level intro of NLP and LDA, terms I'll define here in a sec. Talk about going from a human-readable book format to a machine-readable vector representation of those texts. And then we'll get into a demo, see the cool things we can do with the trained LDA model. So I'll give a brief NLP primer. I know we may have varying levels of NLP expertise in the room, but just so we're kind of all on the same page going in. Let's see. So NLP stands for Natural Language Processing. A token is an individual word. It's kind of the atomic level of our texts. So that's when we process a text document, that's what we get out is a bunch of tokens. A document is a single text that we'll be considering, and it can be any length. It can be a sentence, it can be an article, or it can even be a full book, which is what we'll be looking at today. A corpus is a collection, Latin for the word body, of course. You know, it's the full collection of documents that we'll be analyzing. And stop words are common words that don't contribute to document meaning, but they are words that we'll be removing because they're not important. So they're grammatically necessary for us, but we don't care about them. We'll be taking those out. In English, those are words like a, and, there, so on. Final term is a bag of words. So a bag of words is a simplifying representation. So we lose grammar and readability, but what we gain is machine readability. We take all the words out, we assign them indexes and kind of throw them into a bag. For the data, I use Project Gutenberg. It's an online repository of ebooks. It's pretty large. I went ahead and used all the English language ebooks available. That was just under 10 gigs of data. So now I'm going to give us a really brief overview of LDA. LDA is something I could talk for 20 or even 50 minutes about just on its own. But here we'll focus on what we need to know. LDA stands for Latent Dirichlet Allocation. It is a generative probabilistic topic model that projects a user-specified number of topics onto a corpus of documents. And so using the inputs, it infers a hidden structure in the corpus, assuming a Dirichlet distribution. So there's a lot of data science terms and jargon I just threw out. What I want us to take away for today is we feed our LDA algorithm a bag of words format corpus. We get an LDA model out, and we gain lots of information with a trained LDA model. One of the specific outputs I'll be talking about a lot is a document topic vector, something I'm calling a document topic vector. Several enabling technologies I used in this work. All of my topic modeling I did in GenSim, which is a Python library for various NLP tasks, but a lot of people do use it for topic modeling in particular. Training an LDA model is fairly computationally intensive, so I gained additional computational resources by using Amazon Web Services EC2s. And then I used Jupyter Notebooks to kind of make a nice interface to play with the models and check out all the results that came out of the scripts. Another piece of enabling tech I want to mention is Project Rambo. I partnered with a local Python consulting agency here in town, Terminal Labs, I think Michael's here, to use their open source Project Rambo, which uses Vagrant and Anaconda to provision virtual environments and then make the development environments reproducible. So we configured the development environment once, and then I was able to spin up as many as many duplicates of that development environment as I wanted, which is convenient when you've got an LDA model training that can take 4 or 5 hours on a large corpus. I can just set that to run and do it 5 in parallel. Not only is that convenient, but it also makes the work reproducible, which is something we'll be talking a lot about here today. So I can do it and reproduce it myself, and then also others can reproduce it. And we all know good science is reproducible. So that was a big bonus to this project. It does support multiple platforms. You see those listed there, and it also supports containers. So now we're going to go into demo time. Any questions while I'm transitioning over here? Oops. Okay. So, all right. So now we've opened up a Jupyter Notebook, got a lot of code in here. I'm gonna kind of go over some relevant results. I do want to mention at the start here, there's a lot of enabling code that you don't see up above here. These notebooks are available on the GitHub repository for this project if you do want to get deep into the code. But for today, we're just going to really focus on results since it's a 20-minute time slot here. We'll be looking at exploring and visualizing the model. We'll look at then, so then we'll have our model, we'll kind of understand it. We'll look at document similarity we can run on it. And then we'll do something that I'm calling book algebra, which I'm very excited about. That's kind of the grand finale of the talk. So let's get into that. So let's explore our model. So the LDA algorithm, it clusters topics. It goes through and calculates all these words and how they're related to each other. What it doesn't do is give us any interpretability for the topic. So I've gone through here and assigned some topic designations. So within our corpus, we have words like, let's go back up here and look at all the topics quickly. So we've gone and asked our LDA model, hey, what topics do you have? And our LDA model says, well, I've got a bunch of topics. I have one topic here that includes words like species, development, scientific, another word that includes topics like machines, steam engines, kind of engineering words here. We have a topic that includes words like knit, thread, cotton. So LDA has taken all of these terms and realized that they occur together in documents. And this is cool. I just want to step back and say, we just fed our LDA model a bunch of processed text, and LDA came back and clustered all these words together for us. It does not, however, assign them topic designations, so I went through and manually did that for 38 of these topics. I found 38 of these 50 to be very easily interpretable, and so these are some of the topics that we came up with in this model. So now we have a model. We kind of see that it has a bunch of topics that are a bunch of word clusterings. But let's take a look at a visualization of this model. That's a really nice way to view it. So I've previously generated and saved an HTML version of this PyLDA viz chart. 2 lines of code, and I got this chart out, which is pretty neat. And what PyLDA viz does for us, I review here. So it's a 2-dimensional visualization of all of our topics. A few words just before we dig into the chart itself. So the axes themselves are not interpretable. They don't have a meaning. These 2 axes came out of a multi-dimensional scaling algorithm where the algorithm took it down from n-dimensional space to 2 so we can view them in this 2-dimensional flat format. It did that maintaining as much of the information about the topic distance as possible. And we'll see that it did a pretty good job capturing the really relevant relationships between topics. The size of the bubbles have to do with the percentage of the tokens in the corpus that the topic contains. So let's see, topic 4 here, which we'll look at in a sec, contains 4.5% of the tokens in the corpus. So you can think of it as, it's a big topic, contains a lot of words, whereas a small topic, a specific topic, contains not a lot of words. So let's go ahead and take a look. Let's see what we can kind of learn from this chart as far as visualizing our topic model. I've got an example here. So topic 15, I've termed ancient Rome. We see it contains words like Rome, Greek, Italian, Pope. So clearly these are words related to kind of ancient Rome and Italy. Close to it is number 12 here, which I've termed the Judeo-Christian topic. So it has words about religion, Christ, spiritual doctrine. So those are all kind of in the Judeo-Christian tradition, right next to ancient Rome. And then overlapping with that and right next to it is a topic that I've termed kind of European church and state, from a time when those were pretty thoroughly intertwined. And that includes words like parliament, Catholic, religion, France, Duke. So this topic knows about all those kinds of words and that they're related to each other. So, and they're all kind of clustered nice and tight. They occur together. Those are all things that are related. And so they show up close together on our PyLDA viz chart. But then what about some outliers? Let's look at topic 30 here, which I've termed the baking topic. So it looks like our corpus contains some recipe books, and we have words like milk, boil, butter, sugar, eggs, cream. Those words in that topic, those are pretty specific to recipes, and so those books in that topic are not closely related to other topics, and we kind of see that should fall out of this visualization. So that is PyLDA viz. It's just really super useful for an overview to see, I've got this topic model. It's this big, huge chunk of data. I think this one's like a gig or two of size on my disk. And this you can kind of look at it and see, what is it? Just do some kind of preliminary exploration of what your topic model is telling you. So with that, let's switch back over to the notebook. And now that we've kind of gotten that nice high-level overview look at things, let's get a little more into the raw results of the topic model. Our topic model has learned relevant topics for a document. So if I execute this cell, we're looking at the King James version of the Bible here, and it pretty much contains one topic according to our model, that topic, and I've designated that religious scripture. So that checks out, the Bible, pretty much religious scripture. So we'll come back. But we can also do that same thing for a word or a term is an NLP phrase for that. I looked at the word France because that, France is an old country, has a rich history and culture, so it should have some really interesting topics associated with it, and it does. So the word France is associated with the French language topic, French royalty topic, an economics and sociology topic, European war, European church and state, Spanish colonialism. Our topic model has learned that all of those topics that France is related to all of those topic clusterings. So that's pretty cool. So that's kind of our exploration of the model, wrapping up that section. We're moving into kind of the last part of the talk where we're going to look at document similarity and then our kind of fun book algebra demonstration. But so we have these vectors now, right? We've done a lot of work and we've trained our model to have all these mathematical representations of all these different things. And now what we have is relatively low dimensional vectors. So they're n-dimensional row vectors. For the document topic vectors, which we'll come back to, they're 50 long because we trained on 50 topics. But what we'll use to examine those and to numerically quantify their similarity to one another is cosine similarity, which some of you may be familiar with, but it's a calculation that gives you a number between, it gives you a number that tells you about the topic's separation from one another, or a vector separation, in this case a topic. And I want to step back a sec and just say, so that the LDA model, one thing we can get out of it is this thing, document topic vector, which I mentioned before. That is LDA's representation of what topics constitute a document. So I've pulled up Pride and Prejudice here. That's a book a lot of people are familiar with. And the LDA model has decided that Pride and Prejudice is about 30% of topic 10, whatever that is. And a lot of these are essentially zero, this 2 to the negative 6, that's kind of LDA's way of saying they're not related. But, it's 30% this, 40% that, and so on. And we represent that mixture of topics with this n-dimensional, 50-dimensional vector. And we're going to do some cool things with those and cosine similarity. I've written a helper function here to find our most similar vector in the corpus to Pride and Prejudice, and let's see what it found. So Pride and Prejudice, it finds a duplicate of itself. Gutenberg actually contains several duplicates of some really famous texts. But in addition to that, it finds some other 18th and 19th century literature, but also result number 3 is Emma, our topic model knows that Pride and Prejudice and Emma have very similar topic vectors, which I thought was super cool. If anyone likes Jane Austen, you'll know that that's another Jane Austen book, as is Northanger Abbey. So in our top, I think 11 results of most similar documents in the topic, document vectors in our corpus, 2 of them are Jane Austen books. So our topic model did a pretty good job of getting Jane Austen's number, I think. So let's do another example of that similarity, coming back to our King James Bible. And this one is perhaps even more interesting, and not trying to make any statements or take this to any place of discussion, but documents that our topic model thinks are similar to the King James Bible are, again, duplicates of the King James Bible, but also the Quran and other, 5 minutes, other translations of the Bible, the Book of Mormon. Interestingly, the Iliad, I guess the ancient text kind of thing, it triggers that same one as the Bible, as well as some scholarly works on the New Testament. And so I just thought that was interesting. Our topic model thinks that those texts are similar. So now, grand finale of the talk is book algebra. So we have these 50-dimensional document topic vectors, and they are just vectors. They're vectors that we can add and subtract and do other things with. So we're going to go and do that. We're going to add and subtract some document topic vectors, and what we will find after doing that is books in the corpus that are most similar to that sum or difference. So here I have subtracted the Bible from Pride and Prejudice, because that's something we can do with our document topic vectors. And our corpus, our model thinks our helper function has determined that most similar to the difference of Pride and Prejudice is actually the same list that came out of Pride and Prejudice when we just looked for straight similarity to that. So why is that? I think this checks out because Pride and Prejudice does not really contain that religious scriptures topic. And so when we took it out, I didn't let them go negative because it doesn't make sense. When we took it out, we really didn't actually take anything out of the text. So it's kind of Pride and Prejudice minus the Bible is the same as Pride and Prejudice. However, if we go and add them up, we get something different. We get some other kind of obscure 18th and 19th century literature, and possibly even older. That's one interesting thing about Gutenberg. A lot of the texts are kind of obscure. But some interesting results are we get a Shakespearean comedy. Apparently, the Bible plus Pride and Prejudice is similar to Shakespearean comedy. And we also get this really interesting result. I was giving this presentation to a friend as a practice, and she was like, "Oh my gosh, this book is about a priest falling in love with a young girl." So, so we get kind of those romantic love and religious themes existing together. So it's like, all right. So let's do a couple more demos of this, and then I'll wrap it up. So I've looked at 20,000 Leagues Under the Sea. That's a famous kind of classic novel, and I'm taking out of it this book that's pretty much about ships. It's pretty much a dead-on match for the ship's topic. So basically, I'm subtracting ships, marine, going, whatever, out of 20,000 Leagues Under the Sea. And what we get out of that is a bunch of kind of naturalism and adventure books, but nothing having to do anything with the ocean. So we've taken 20,000 Leagues Under the Sea, and these are what you get out when you do that. And finally, because I have kind of a dark sense of humor and I thought this would be super fun, I want to add up Alice in Wonderland, Lewis Carroll's kind of fantastical nonsense children's story. I want to add that to Joseph Conrad's Heart of Darkness, which is about, the evils of imperialism and the worst of human nature and all that. And what we get when we do that, we get kind of an interesting mix. Again, not super familiar with any of these books, but especially some of these titles here: Day of the Druid, Shadows in Zambula, Shadows in the Moonlight. Those to me kind of sound like books about supernatural occurrences in the wilderness with dark and mystical themes. So if you really like both, Alice in Wonderland and Heart of Darkness, some of these may be some good books to check out for your next book. So so with that wraps up our demo. I have just a couple more slides, and then I'll open it up for questions. So hopefully in this demo, I've kind of, taken you through some of the utility and power of doing a topic model or just general NLP project. But the good news is you don't have to take my word for it, because this project is fully reproducible due to this Project Rambo integration that I mentioned earlier in the presentation. So with that work, so I've coded all this up to be and posted it on GitHub, along with some replication instructions to be completely reproducible. So you can go, you can clone the repo, follow. I have a markdown file on the repo that tells you about how to step-by-step replication. So if you are, kind of interested in data science, kind of interested in NLP and specifically LDA topic modeling, this repo contains a clean data set or access to a clean data set, some Python scripts, and then some Jupyter notebooks to go do modeling and then play with the model and results. So I think that wraps up the presentation here. I'll say thank you all very much. Thanks so much for coming out. It was really great to give this talk to you. Again, my name is Rachel. I'm a recent graduate of the Galvanized Data Science Immersive Program, and here's all my contact information, all the various places on the internet you can find me. One thing I do have, quickly, I have some cards up here. I got these printed up, and they just have a place where you can go and do the replication that I talked about. So it's my card and then directions to the GitHub. So with that, I think I am done. And do I have any questions? Yes.
How did the model deal with like regional specific or colloquial words?
So I did not. Oh, yes, sorry. The question was, how did the model deal with regional specific or colloquial words? That is something that you can do in your text pre-processing. It was not something I did. And you notice like only 38 of my 50 topics were interpretable, and I think there's a lot of tuning that, a lot of opportunity for tuning that I still have in my text processing, as well as my model tuning parameters. So it is an ongoing project, and I would like to get some of that in there. So the answer to your question is it's not accounted for right now, but it could be. And also, kind of making a bug a feature, what it does kind of do is it allows those books that are regional or colloquial, or King James kind of came up differently because it had kind of those Old English type words. It separated those out into their own topics. So, that's kind of the answer to the question there. Yes.
And so was this like a thesis for the Galvanized program? And also, what's your background other than Galvanized?
Yeah. So this project this talk is an expansion of my. Oh, sorry. Repeat the question. The question was this project a thesis for Galvanize, and what's the rest of my background? This talk that I gave is an expansion of the capstone project I did for that immersive course. So I got about 3 weeks on it there, and then I spent the last month and a half, kind of spiffing it up and making it everything I'd wanted it to be. My background before that, I have a chemical engineering bachelor's, and then 7 or 8 years of work in like product, so electronic product, and then like program management and in department management. So that's what I've done before this, and kind of transitioning into the data science field. Yes.
So is the major application to like pair it with a book rating application, and basically replace a librarian?
So the question is is the application of this to create ratings and replace librarians? I have not taken it that far. I think definitely, and I didn't get much into the potential applications of this. I didn't touch on that at all. I think one thing you could do with this is a recommender system. So I just kind of in passing mentioned at the end, these are some books you could check out if you like these 2 books, or if there was a book you're like, oh, I really like this book, but I'm not into ships, then you can figure out what's similar to 20,000 Leagues Without the Ship. But I don't think I'll be replacing librarians anytime soon. I'm sure that there are some interesting applications of how you can use machine learning in libraries and automate some manual information collection. But I think there would be ways to go before I could be replacing librarians. This is a good question. Thank you. Yes.
Have you considered extending this to medical text? I think your topic algebra would be incredibly useful to pathologists.
Oh man, I have not, but that does sound super interesting. Actually, yeah, I would love to think about doing that. Thank you. Oh, sorry. Question was, have we considered extending to medical texts? And my answer was, I have not, but I probably should. So yes.
You said that the number of topics was something that you chose.
Correct.
Was there a way that you arrived at the number 50?
That was strictly trial and error. I think I trained on like 10, 30, 40, 50, 60. And so at 50 was the one that gave me kind of the best results. Like I looked at it, and those results make the most sense. There are additional things you can do. And actually, again, I didn't repeat the question, was how do you choose the number of topics? There are things you can do once you have chosen. There are calculations you can run. I think topic coherence is a method that Jensen makes available. So you can run topic coherence and get some numerical measurement of like the goodness of your topics. It's a little bit of a black art. Like sometimes, I don't know, sometimes like that number will not correspond to actual human interpretability of those topics, but it is a useful thing. So to answer your question, it was kind of selected through trial and error. You know, that's one reason I needed to run so many instances of those virtual machines to train the model. Yeah, you just try a bunch of numbers and see what gives you the best results. Yes.
How much computing power does it take and how big is the data? And tell us about this.
Yeah, so that's a great question. So I have, on the reproducibility version of the project, it's all written for a T2 extra large EC2, which I think it has 4 cores and 16 gigs of memory. That is doable with a corpus of 5,000 books, or a corpus of 5,000 books is doable on that. However, this 28,000 book topic model that I got required kind of a beast of an EC2, and I think it was like $2 an hour. It was something just insane. I have free credits from Galvanize, so I was like, sure, whatever. But it was like 40 cores and 256 gigs of memory or something insane like that. So that is one area of continuing work for the model. I would like to be able to run, to modify my script so this model is more runnable on less hardware intensive, either physical machines or virtual machines. But for anyone interested in reproducibility, with a text of 5,000 a corpus of 5,000 texts, you should be able to run it on an Amazon Web Services T2 XL with, and I think that's like 10 or 20 cents an hour. It's pretty reasonable. So yeah. Any more questions? Yes.
Have you given any thought to integrating with sentiment analysis? So you can answer the question of what topics are in this book, but then, well, is it pro this topic, or like money is mentioned so many times in the Bible, right? But
Yeah.
is it antagonistic, or is it protagonistic in its attitude toward money? I mean, or whatever.
Oh, interesting. Yeah, so the question was, have I considered incorporating semantic analysis into this work? I have not. I think that's super interesting and would be really cool. Yeah, I haven't, but again, probably should. So, great question. Any more? Yes?
I know that like sometimes with LDA you can find really obvious topics, really clear topics, like maybe the steam engine or something like that.
Mm-hmm.
And you can, of course, also, if you generate enough of them, generate some kind of confusing or nonsense topics, or it's not clear why they apply onto a book. Did you have anything that you thought was really surprising or really confusing that you dug into?
Okay, so the question was just kind of talking about, the interpretability of the topics that came out of LDA, and were there any kind of weird or surprising things I found. One thing that came out of my topic model that drove me crazy and that I really want to go through and kind of solve for in the next iteration of this project, I got these like name topics. LDA, it went and clustered all these names together, and there were things like, Mary, George, Oswald. Some of them were all kind of like British sounding or kind of like German sounding, but apparently something about the LDA algorithm picked out these names and decided that those needed to be a topic together. I think it has something to do with, LDA is trying to optimize between minimum number of terms make up a topic and minimum number of topics make up a document. And names are something that'll reappear in a few different documents, but not all of them. And so I think that's why LDA was like, oh, cool names. Those are some topics for me. So that was one result that was kind of interesting and surprising that came out. Another one is I had this pretty big topic, number 2, that contained both words about kind of like that I interpreted as like kind of honor, and then also words that related to Japan. So I would like my topic model to, kind of distinguish between, things specific to Japanese culture and then kind of just like general global honor type topics or words, terms. But at least in this run of it that I did, it failed to do that. So those are some interesting results I found.
Kind of in that vein, is it possible if, your output is 50 different categories that you assign topics to, if you have 20 that are really great and then there's 30 that you kind of like, let's try this again, can you kind of assign a subset to get re-assigned or anything?
Okay. Question is, basically, if we get kind of junk topics, can we throw them out and just focus on the good ones? Is that inaccurate? Yeah, I don't think so. I could be wrong. Don't hold me to this, but I believe you kind of have to approach the corpus as the corpus and the topic model as a, monolithic thing. You train it, and it kind of gives you what you get back, and I think that's kind of the extent of your ability there. I think what you can do is lower your number of topics. Like if you really only found 20 coherent topics, you can reduce that number maybe to 20 or 25. And then some of the things like, I mentioned I had some words, those names in my corpus that were kind of giving my LDA model some struggles and giving it some, not great results. I would like to just take those names out of my dictionary, my vocabulary for the corpus. That's something you can do is if you have terms that are giving you kind of junk, kind of garbage out, you can take those out of your LDA inputs. But so I think not directly to what you're saying, but I think there are ways you can kind of work around it. Anything else? Cool. Well, guys, again, thank you so much for coming. I'd love to, if anyone has thoughts or would like to chat about it further, please find me during lunch or the rest of the day and any of those contact information places. So thank you all very much.